Hi, Math Analysis. So we are going to do section 10.5 today. There's an A and a B. These are the notes for both A and B. So binomial expansion. So binomial expansions are when multiplying out binomials raised to a power. So when we've got x plus y squared, we all know how to FOIL that out. But when we have x plus y to any larger power than squared, this is what we're going to be talking about today. So if I were to multiply out x plus y times x plus y times x plus y, it would be, and I'm going to show you how to get this, it would be x cubed plus 3x squared y plus 3xy squared plus y cubed. And you can see that I have x plus y to the fourth already multiplied out and x plus y to the fifth. So I'm going to show you how to get those without having to go through long FOILing processes. So if the exponent is n, then the expansion will have n plus 1 terms. So you notice x plus y to the squared has 3 terms. X plus y cubed has 4 terms, and so on. If the exponent is n, then the first and the last will be the power of n. So x cubed at the front and y cubed at the back, x to the fourth at the front, y to the fourth on the back when n is 4. So, in successive terms, the exponent of x decreases by 1, and the exponent of y increases by 1. So you want to notice that. The sum of the exponents in each individual term adds up to n. The coefficients are symmetrical, as you can see below. You start with 1, you end with 1, and it goes up. And then when there's an even number of terms, there's 2 the same in the middle, and when there's an odd number, there's a single in the middle. And this is Pascal's triangle. And the way to get Pascal's triangle, if you look at the third row, that's the 0 row. That's the first row. And so on. When you look at the third row, how to get the fourth row, if it wasn't there, what you would do would be, the third row is 1, 3, 3, 1. So if you add the 1 and the 3 together, you get the 4. If you add the 3 and the 3 together, you get the 6. If you add the 3 and the 1 together, you get the 4, and so on. So that's how you can get the rows of Pascal's triangle. So you use each row. So why don't you take a moment to write that down. Okay, so if you've got x plus y to the fifth, you'd use the fifth row, and so on. You can always pause, too, if you need some more time. You can pause the YouTube video. All right, so use the pattern discovered to expand the following binomial. Use Pascal's triangle and write the 8th row of Pascal's triangle. So if you take a look at the 7th row, so you're going to have to go back over here. When we look at the 7th row and we want to write the 8th row, I'm going to do it from this slide. So we've got 1 here, and then 1 plus 7 is 8. And then 7 plus 21 is 28. And then 21 plus 35 is 56. 35 plus 35 is 70. And then it goes back down to 56, 28, 8, and 1. So once you get to the middle, you can just go backwards. So as we go over here and answer this question, that's the same thing there. I just wanted to do it on the slide where it had the numbers. So there you go here. So again, going through the process, as you can see. Okay, so x plus 3. So the y term is now 3. So we're going to use the third row of Pascal's triangle. So we've got 1 x to the 4th. Then we've got 4, because that's so you've got the 4th row of Pascal's triangle, which is 1, 4, 6, 4, 1. Okay? So that's where I get those numbers. Then the x goes down with degree, so x to the 4th, then x to the 3rd, and then the 3 goes up in degree. And you notice that all of those exponents on the x and the 3 add up to 4. We've done this in Algebra 2. Now, because the y term is 3, we've got to clean this up a little. So we don't need to write the 1 in front of 1x to the 4th. And then we need to multiply the 3 and the 4 together. And we got 12x to the 3rd. And then we need to square the 3, so you're going to get 9. And then 9 times 6 gives you 54x squared. And then 3 to the 3rd is 27. 27 times 4 is 108x. And then 3 to the 4th is 81. Okay? All right. The next row, 6th row. Here it's minus. So we are going to alternate plus and minus signs. That's what happens when it's minus. So you've got 1x to the 6th. Then you've got minus 6x to the 5th, 2y to the 1st. You got to make sure it's 2y, not just 2 and not just y. Then you've got 15x to the 4th, and it's 2y raised to the 2nd. And then you alternate the plus and minus signs. So that's why the first minus, plus, minus. So then you've got 20, and I took 20 from the row of the Pascal's triangle, what I have in blue. Then it's x to the 3rd because the x's are going down and the two y's are going up. So it's y cubed. The exponents always add up to 6 in each term. So then we go back down to 15. X exponent keeps going down. The 2y exponent keeps going up. And our last term here, and we alternate plus and minus. So now here we've got to clean it up. So we've got to multiply 2 and 12. And then we've got to square the 2 to get 4 and multiply it by 15. So 16. So 4 times 15. Then we've got to cube the 2, so that's 8 times 20, 160. Then we've got to raise the 2 to the 4th power, so that's 16 times 15, so that's 240. Then we got to raise 2 to the 5th power, that's 32 times 6, which is 192. And then 2 to the 6th power is 64. And that's your answer. Okay. All right. Again, please request a Zoom session if you have any questions. Okay. So moving along. Again, you can always pause. So we are not always going to ask to expand the whole thing. We might just ask for a term number. And so we've used combinations before, NCR, and that is n factorial over n minus r factorial times r factorial. But you can just use your calculator to find it as well. So there is, if you go to the probability key, you plug in 6 probability and you go down to combinations and then you plug in a 3. But you could also say it's 3 factorial over 3 factorial times 3 factorial, because you minus the 6 and the 3 to get 3. And then you can just plug that into your calculator. Please request a Zoom session if you don't know how to plug it into your calculator. And again, this is just a different notation, but it means the same thing, 6C0. And that one's pretty easy to solve because you just cross it out and you know it's 1, and 0 factorial is 1, and that's something we should always know. So this one's also 1. So again, there's a factorial button in the probability section of your calculator too. So please request a session if you can't find how to do that on your calculator. And factorial, as you know, means like 12. If 12 factorial is 12 times 11 times 10 times 9 times 8 times 7. And we've done this before. So we've got those combinations. That's 5 factorial over 5 minus 3 is 2 factorial, then 3 factorial, and so on. So you can get the last one. So just practice these on the calculator. Pause, figure out how to do it on the calculator. I'm happy to help you. All you got to do is email me to hkaiser@auhsdschools.org and say, can I have a quick Zoom session so you can help me with my calculator? Okay? All right. So we're going to use this formula. So NCR, and it says use the binomial theorem to expand x plus y to the 7th, and I want term 1. So when you want term 1, r is 0. When you want term 2, r is 1, and so on. So r is always 1 less than the term number. So this is how to do it without using Pascal's triangle. So that would be the first term. The second term, r is 1. So it's going to be 7C1, which again, you can just use your calculator for 7C1. And then if you remember, r is 1. R is on the y variable. Third term, r is 2. R is also always on the second variable. 7C2, you could just use the calculator. Find 7C2. It's under math probability in the graphing calculator, if you have one, or there's a probability key on the scientific. So again, please let me know. I'm happy to show you how to do that. All right, and the last one, 7C3, there you have it. So in the expansion of x plus y to the n, r is always 1 less than the term number. So we're going to use this formula. So in this case, n is 10, and they use k here, but that's r, same thing. R is 3. So r is term number, so this is r. R is term number minus 1. Okay? So if you want the fourth term here, r is going to be 3. So n is 10, r is 3. So you've got 10C3, and you've got x to the 10 minus r times, and then y to the r. So r is always the exponent on the second term. So take your calculator, find 10C3, and there you go. A minus 2 to the 6. This time we're going to use it as negative 2 because we don't know whether the term's positive or negative. So again, n is 6 and r is 2. So it's going to be a to the 6 minus 2 and negative 2 squared. So you're going to find 6C2 on your calculator. And that's 15. A to the fourth and negative 2 squared, which is 4. And then you're going to multiply the 4 and the 15. All right, the fifth term. So what is R going to be? 1 less, so R is 4. N is 10. So it's 10C4. Find that on your calculator. 2x raised to the 10 minus 4, which is 6. And then negative 3 raised to the 4. Okay? Then you're going to find 10C6 on your calculator. You're going to raise 2 to the 6th power, which is 64. And you're going to raise negative 3 to the 4th power, which is 81. Then you multiply all the numbers together and put your exponents after. Okay? All right. 17th term. That means is 16. So 20C16, 2a to the 4th, b to the 16th. So 20C16 is 4845. 2 to the 4th is 16, and then you multiply that. Again, pause the video if this is going too fast. Okay? All right. Thanks, guys. So this should go for 2 assignments. This video should work for the 2 assignments, 10, 5A, and B. Please email me again for any Zoom sessions. I hope you guys are doing well and staying healthy.